Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 6 in the directory traversal module titled File Path Traversal with Null Byte Bypass. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, and select the learning path. Go down again and select directory traversal. And then go down one last time to lab number 6, titled File Path Traversal Validation of File Extension with Null Byte Bypass. Alright, let's get started. This lab contains a file path traversal vulnerability in the display of product images. The application validates that the supplied file name ends with the expected file extension, so it needs an expected file extension. To solve the lab, retrieve the contents of the passwd file. Okay, so the target goal over here is to exploit the path traversal vulnerability and retrieve the contents of the passwd file. Okay, let's open the lab. Now notice over here, this is the inbuilt browser in burp. And so if we go to proxy right over here, all the requests are being intercepted in my proxy. Now this is the same application that we've been dealing with in previous labs. It retrieves images from the server, and the request that is responsible for doing that is this one over here. So we're going to send that to repeater and evaluate if this request has any vulnerabilities in it. Now, anytime you see a user-supplied input that could potentially be retrieving content from the server, you should test it for vulnerabilities like path traversal, RFI, and LFI. And today we're going to test it for path traversal. So if we hit send right over here, you could see it's a 200 OK message, and it displays the content of the image 48.jpg. Now let's assume we tried everything that we tried in the past 5 labs and it didn't work. So the next thing to try is to see if there's some kind of defense mechanism that requires that you have this specific extension for the request to go through. So the way to kind of bypass that is to add the file that you want to view. So let's say .. // and then etc passwd. And then what you could do is add something called the null byte, which is represented using these characters in hexadecimal. What that does is essentially says ignore everything after the null byte, and so it'll ignore all of this. And what will be processed in the backend is this specific string over here. So let's bring that back and test it out. And here we go, it works. So we get the content of the passwd file. Now, this doesn't always work for every application. It depends on the language that you're using and the framework that you're using and how it's being processed in the backend. But when it does work, it allows you to bypass certain defenses that are in the backend. So if we reload this page right over here, you should see the message that says, congratulations, you solved the exercise. And we do. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. So the whole exploit is done using a single request, which means that our script is going to be relatively small. The first thing that we're going to do is import all the libraries that we need, which is the sys library, the requests library, and the URL lib3 library. And then we're going to disable insecure request warnings. So URL lib3.disable warnings, URL lib3.exceptions.insecure request warning. And then we're going to set our proxy setting. So proxies is equal to HTTP. And then HTTP 127.0.0.1. port 8080. What that does is it says send all HTTP traffic to where burp is running, and this is incorrect. It should be 127.0.0.1. So it's running on localhost on port 8080. Same goes for HTTPS traffic. So HTTP 127.0.0.1 port 8080. Okay, this looks good. The next thing we're going to do is create our main function. So if name is equal to main, then call the main function, and we'll define the main function right over here. So if the length of the command line arguments is not equal to 2, so the user ran the program incorrectly, then we'll print the usage instructions, which is the name of the program and the URL of the vulnerable application. And the name of the program we'll take from the command line argument. And then we'll also print the example instructions, which is the name of the program and the sample URL. So let's say www.example.com. And the name of the program, again, we take from the command line argument. And since the user ran it incorrectly, we'll exit the program after it prints the usage instructions. All right, so let's assume the user did run it correctly. In that case, we create a variable called URL, and we set it to the second command line argument that the user supplied. And then we'll print the statement exploiting the directory traversal vulnerability. And we'll do that using a custom function that we're going to write called directory traversal exploit that takes in the URL. Okay. This looks good. Now let's define our function. So def directory traversal exploit, which again takes in the URL. The first thing we're going to do is set the path to the vulnerable function. So we're going to call that image URL, and that's equal to the URL of the application plus the URL, the path to the exploit, which is this one right over here. So let's copy that and put it in here. And then we just perform the request. So request.get, it takes in the image URL. We use get because it is a get method. And then we say verify is equal to false because we don't want to verify TLS certificates, and proxies is equal to proxies because we want the request to be sent to burp. And then we need a way to verify that the exploit worked. So we're going to say if this specific string is in the response of our request, so is in r.text, then print exploit successful. Also print the following is the content of the passwd file, and we'll print it using the r.text by dumping the response of the request. Now, if we don't find that string, that means our exploit didn't work. And so we'll print exploit failed, and then we'll exit the program. All right, let's save that. This looks good. So if we review it, essentially we check if the user ran the program correctly. If the user did run it correctly, then we call this function over here, which is responsible for exploiting the path traversal vulnerability and dumping the content of the passwd file. Now let's see if there's any errors in the program. So Python 3, and that would be directory traversal lab 06. .py and the URL of the application, which likely timed out, and it did. So let's access it again. Let's copy that, put it in here, hit enter, and here we go. It says congratulations, you solved the lab, and you could see over here it says exploit successful, and it dumps the content of the passwd file. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python.